We're now going to extend Vietta's formulas to quartic equations. So given the quartic polynomial ax to the 4 plus bx cubed plus cx squared plus dx plus e, where the 5 coefficients are real and a is non-zero, and roots alpha, beta, gamma, delta, we can do exactly the same as we did with cubics. We know x minus alpha, x minus beta, x minus gamma, and x minus delta are factors of this quartic. And so we can write ax to the 4 plus bx cubed plus cx squared plus dx plus e as alpha as a lots of x minus alpha, x minus beta, x minus gamma, x minus delta, and now let's expand the right hand side. So these two brackets give me the quadratic x squared minus alpha plus beta x plus alpha beta, and the other two brackets give me x squared minus gamma plus delta x plus gamma delta. And then let's expand again. So the only term with x to the power 4 is just 1x to the power 4 from x squared times x squared. The two cubic terms come from this x term times x squared and this x term here times the other x squared. So we're going to get minus alpha plus beta plus gamma plus delta x cubed, and then we've got, to get x squared terms, we can have alpha beta x squared or gamma delta x squared, or the two x terms multiplied together. So that's alpha beta plus gamma delta x squared, and then also alpha plus beta times gamma plus delta x squared. And then to get an x term, we either have this term here times the constant over here, or this constant here times this x term. So that's minus gamma delta times alpha plus beta x, and then minus alpha beta times gamma plus delta x, and then the constant is alpha beta gamma delta. And now let's equate some coefficients. So if we equate x cubed coefficients, we've got b is minus a times alpha plus beta plus gamma plus delta. So again, we have the sum of the roots is just minus b over a. And now if we equate the x squared coefficients, we get c is a times alpha beta plus gamma delta, and then from these brackets we also get alpha gamma plus alpha delta plus beta gamma plus beta delta, and so we see the sum of the product of two roots is c over a. C over a is alpha beta plus gamma delta plus alpha gamma plus alpha delta plus beta gamma plus beta delta. And then if we equate the x coefficients, we get that d is equal to minus a times, well, let's expand the brackets here. We've got alpha gamma delta plus beta gamma delta plus alpha beta gamma plus alpha beta delta. So the sum of the product of three roots is going to be minus d over a. And then if we equate the constant terms, we'll just do that here. So if we equate the constants, we're going to get, well, we can see a times alpha beta gamma delta is e. So we're going to get alpha beta gamma delta is e over a. And then from the x coefficients again, just to write it down, we get that alpha beta gamma plus beta gamma delta plus alpha gamma delta plus alpha beta delta is minus d over a. Okay, so again, so this time Vietta's formulas, we've got 1, 2, 3, 4 formulas. And these extend in the natural way to Quartic equations and other polynomial equations. The pattern is minus b over a is the sum of the roots. The product of pairs of roots is c over a. The product of triples of roots is minus d over a. The product of 4 roots is e over a. The product of 5 roots minus f over a. Product of 6 roots, g over a, and so on. And you just keep going until you run out of coefficients. So this notation is not always the best because we have lots and lots of terms. So slightly better notation is this cyclic notation. So the cyclic sum of alpha is just the sum of all the roots. The cyclic sum of alpha beta is alpha beta plus alpha gamma plus alpha delta plus beta gamma, and so on. It's just all the products of 2 distinct roots. And the sum of alpha beta gamma is the sum of products of 3 roots, and so on. A different way people write this sometimes is psych, and then some expression. For example, if I write psych of alpha squared beta, and if we have 4 roots again, this would just mean alpha squared beta plus beta squared gamma plus gamma squared delta plus delta squared alpha, and so on. So this notation, you can use this if you want, if you have lots of roots, just slightly more convenient. Okay, so now on to this example. The equation x to the 4 plus 2x cubed plus px squared plus qx minus 60 equals 0, where p and q are some constants, some real constants, has solutions alpha, beta, gamma, and delta, where gamma we're given is minus 2 plus 4i, and delta is its complex conjugate, minus 2 minus 4i. Question is show that alpha plus beta is 2 and alpha beta is minus 3. So there are a couple of ways we could go about doing this. One way would be to use Vietta's equations, because we know that the sum of roots is minus b over a, and we know b, it's 2, and we know a is 1. So the sum of roots is minus b over a, which is minus 2 over 1, and the sum of roots is alpha plus beta plus minus 2 plus 4i minus 2 minus 4i, which is minus 2, and this gives us alpha plus beta. We've got a minus 4 over here, so if we add it to the other side, we're going to get 2. And then if we look at the minus 60, the product of all 4 roots, alpha, beta, gamma, delta, is e over a, so that's minus 60. So alpha beta times minus 2 plus 4i minus 2 minus 4i is minus 60. And then what happens if we multiply these together? We get 4 minus 16i squared, that's 20. So alpha beta is minus 60 over 20, which is minus 3. And then we need to find, so that was a, and then we need to find alpha, beta, p and q. So let's find alpha and beta first. We've got 2 simultaneous equations with alpha and beta in them. So from this equation, if I call it star, if we rearrange star, we get alpha is 2 minus beta, and then if we substitute into this, we have beta, 2 minus beta is minus 3, which is equivalent to, if we rearrange a bit, 2 beta minus beta squared is minus 3, so beta squared minus 2 beta minus 3 is 0, and this factorizes as beta minus 3, beta plus 1 is 0. And so therefore, well, beta is either 3 or minus 1, and alpha is the other of those two numbers. Yeah, because we can see if we put beta as minus 1, we'll get alpha as 3, and if we put beta as 3, we'll get alpha as minus 1. So alpha, let's say, is minus 1 and beta is 3, or the other way around. It actually doesn't matter. Okay, and then we want to find P and Q. So again, let's use Vietta's formulas. So P is the x squared coefficient, which is, that's C, isn't it, in Vietta's formulas. So we know C over A, or P over 1, is going to be equal to the sum of alpha beta, the sum of the product of two roots. So we just need to work that all the different combinations out. So we have minus 1 times 3, minus 1 times minus 2 plus 4i, minus 1 times minus 2 minus 4i, and then we have 3 times minus 2 plus 4i, 3 times minus 2 minus 4i, and then minus 2 plus 4i times minus 2 minus 4i. So that gives us minus 3 plus 2 minus 4i plus 2 plus 4i minus, well, from these two brackets we're going to get minus 12, and then this we worked out before was 20. So these 4i's cancel, and then we've got minus 3 add 4, that's 1, add 8, which is 9. So P is 9. And then to find Q, we're going to use the other formula. We know that minus D over A, which is minus Q over 1, is equal to the sum of alpha, beta, gamma. So the cyclic sum of this, we need to work out the product of triples of roots. So minus 1 times 3 times minus 2 plus 4i, add minus 1 times 3 times minus 2 minus 4i, add minus 1 times minus 2 plus 4i times minus 2 minus 4i, add 3 times minus 2 plus 4i times minus 2 minus 4i. And then let's work that out. So that's, so we get minus 3 times minus 2, that's 6. And then minus 3 times minus 2 is 6 again, because the bit with the i's cancels out in these first two brackets. So that's 12. And then minus 1 times 20 is minus 20. And then this is 3 times 20, which is 60. So that's 72 take 20 is 52. So therefore Q is minus 52. And that's the answer.